Alright, jumping back into thermochemistry, let's talk about some calorimetry. Let's say we have a beaker of water. And this beaker of water, it's about room temperature, about 20 degrees, 25 degrees Celsius. And we also have this really hot piece of metal that we just heated up. We'll say it's iron. So Fe, we'll say it's some iron. And this iron, it has about 10 kilojoules of energy absorbed into it. So what we're going to do is we're going to take this piece of iron and we're going to drop it into this water. So we stick this hot piece of iron into this colder water. Well, what is it you think that happens? Well, hopefully you're thinking about the law of thermodynamics, where it goes from high concentration to low concentration. So all this heat energy is going to leave iron and go into its surroundings. So that means the water will start to absorb that energy as the iron starts to release it. But how much energy will the water absorb? How much energy will the iron give away? Well, the iron's going to keep giving away its energy until it reaches an equilibrium point, a thermal equilibrium. So once the temperature of water is the same as the temperature of iron, that energy transfer will slow down significantly. There'll still be energy lost to the environment around, so energy is to be going out to this environment, but the transfer between iron and water itself is going to be greatly reduced because now they're at an equal state. So we could say the energy of iron is equal to the energy of water. Now this iron, it released its energy and water absorbed it, so we should say iron energy is negative because it released it, making water energy positive since it absorbed it. But from one of our last lessons, specific heat, we know that Q is equal to mc delta T. And this Q is equal to mc delta T. So this energy system of iron is going to be set equal to this energy system of water. And from that, we can solve for any of these variables if we know the other ones. So for instance, if I knew the mass, specific heats, and the initial temperatures, I could find out what that final temperature is of both substances in the system. So what calorimetry is, it is a study of energy transfer and we'll just say between substances or environments. Now this isn't the actual specific definition, but it's one that will benefit us to help us understand what's actually going on. So the study of energy transfer between systems. So we're studying how this energy transfers from this iron to this water until it reaches an equilibrium point. So let's take a more specific example and see what we can figure out. So let's say we got 100 grams of iron, and it's at 120 degrees Celsius. We placed it in 500 milliliters of water, and it's at 25 degrees Celsius. What will the final temperature of this system be? So first thing we need to do is we need to pick out some variables. We need to figure out what's going on. So I have two systems. I have iron and I have water. So I'm going to write out the variables for each. So I got MC delta T for each. So I'll pick out my stuff. I got 100 grams of iron. So that's the mass of Fe. It's at 120 degrees. That's the initial. I'm going to hold on to that information. It's placed in 500 milliliters of water. Well, 500 milliliters is 500 grams because we know 1 gram is equal to 1 milliliter of water. So that's 500 grams of water. It's at 25 degrees Celsius. I'm going to hold on to that information. What will be the final temperature? Now, delta T is the temperature final minus the temperature initial. So I'm looking for this final, so that's going to be X. I'm going to subtract it by the initial, and I got two initials. So each substance will get their own version of this little formula. So delta T for iron is X minus 120. And delta T for water is X minus 25. Alright, then we need the specific heat of water. So that's going to be 4.18 joules per gram degree Celsius. And iron is 0.45 joules per gram degree Celsius. And if you didn't know those values, either your teacher will have them in the problem, or will have given to you to your notes, or possibly even you'd be allowed to look them up. Now I got my information set up, so let's do some calculations. So we know we're using negative Q equals Q. And we know that Q is MC delta T in this case. And MC delta T. Now one of those Q's is negative. In this case, it's the one that's losing heat energy. So the one that starts the hottest in temperature. So iron starts the hottest because it's 120. Water was 25. So the variables of iron need to be on this negative side, this left MCAT side. So let's plug in. So I got negative times the mass, which is 100, times the specific heat of 0.45, times temperature change, which is X minus 120. You can already see I'm going to need more room, so let me just move this over a bit. Set equal to the mass of the water, which is 500, times specific heat, times the temperature change of X minus 125. So now we just got some algebra to do. So let's first simplify this thing down. So negative times 100 times 0.45 is negative 45, and we leave X minus 120 alone for now. I got 500 times 4.18, and I get 2090 with X minus 125. I'll leave that alone for now. Now we distribute into these parentheses. So negative 45 times X is negative 45X. Negative 45 times negative 120 is positive 5400. 2090 times X is 2090. X, and 2090 times negative 25, negative 52, 250. Alright, when we get to this part, we add like terms. So plus 45x cancels that out. Plus 45x. So 2090 plus 45x. 2135. We add 52,000. 250. That cancels. Plus 52,000. 250. Get 57,000. 650. So equal to 2135x. So to get x, we divide by 2135. That cancels. So x equals 57,650 divided by 2135. And we get 27 degrees Celsius. Not too bad. Let's try one more just to make sure we got the idea. Alright, so next problem says if 25 grams of silver was placed in 250 milliliters of water at 10 degrees Celsius, and the water's temperature was raised by 10 degrees Celsius, then what was the initial temperature of silver? Alright, so we got two systems. We got silver, we got water. So let's pick out these variables. So I need MC delta T and MC delta T. Mass of silver, 25 grams. Specific heat of silver, I'm pretty sure is 0.24 joules per gram degree Celsius. And the temperature change, I don't know it. We'll do that in a second. Water is H2O. That's going to be 250 milliliters. So that's 250 grams. Specific heat of water, 4.18 joules per gram degree Celsius. And the temperature change, it says it was raised by 10 degrees Celsius. So the temperature change is 10 degrees Celsius. Now for the temperature change of silver, I need to know the initial temperature. So I got to figure out what was the final temperature. Well, if water was 10 degrees Celsius and was raised by 10 degrees, then that means it went up to 20 degrees Celsius. So if the water was 20 degrees Celsius in the end, so was the silver. So this was 20 degrees Celsius. And I'm looking for the initials, so that's going to be X. Alright, now we can set up our work. So negative Q equals Q, which is negative MC delta T equals MC delta T. So the mass, so I got to figure out which one's negative, which one started the hottest, which one is gaining temperature. Well, water gained heat. Its temperature went up, so that means it's going to be positive. So silver needs to be negative. So I got negative 25 times 0.24 times 20 minus X. Is that equal to 250 times 4.18 times 10. So again, that's the mass, specific heat, temperature change of silver. That's the mass, specific heat, temperature change of water. So now we just kick out some mass, simplify it down a little bit. So negative 25 times 0.24, I'm going to get negative 6 times 20 minus X. Is it equal to 250 times 4.18 times 10, 10,450. Alright, now we can distribute into parentheses. Negative 6 times 20 is negative 120. Negative 6 times negative x is positive 6x equals 10,450. Add like terms. Plus 120, that cancels. Plus 120, get 10,570 equals 6x. So once I get to that point, we divide by the value with x. That cancels. So 10,570 divided by 6 is 1761.7 degrees Celsius. So 1,761.7 degrees Celsius. That silver was pretty hot. And that is calorimetry. So pick out your variables. Figure out which substance goes to the negative side, which substance goes to the positive side, and then just do some algebra. Might seem a little daunting at first, but once you get the hang of it, it gets pretty simple. Hopefully this video helps. And as always, good luck on your tests.